Sathyabama Institute of Science and Technology.
Hello everyone, I am Dr.T.Prem Jacob, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. So today we are going to discuss about the white box testing. So testing, it plays a major role in finding the faults in the software. So here in white box testing, so it is also called glass box testing. So in here, this is a testing method, so which we will be using the control structure to derive the test cases. So in this white box testing, how we are going to design, right? So that test case, right? So that is test case, it has to be designed so in such a way it should guarantee all the independent paths, right? So in a module has been exercised at least once, and you have to exercise all the decision based on the true and false sides, right? And you have to execute all the loops, right? So in their boundaries and their operational bound, and exercise all the internal data structures to ensure their validity. This is a basic path testing. It is one of the white box testing technique. So it is proposed by Tom. And this is a flow graph notation. So in a flow graph, okay, so each circle, right, so it represents the node, right, of that particular flow graph. And if you consider the node, you can map the process boxes and also the decision diamond inside a particular node. And this is a flow graph, okay, and arrows on the flow graph, so it represents the edges, and the arrows, it will always terminate in a node. And here, if you consider a region, so region is nothing but, so the area that is enclosed between the node and the edges, so that we call it as the region. So if you want to find the number of region, right, so in a particular flow graph, okay, so you need to include a region which is outside, right, the flow graph. So in this picture, so you can see the circle, it represents the node, and the arrows, it represent the edges, and the area, so that is enclosed between the node and the edges, so that we call it as the region. And the region, right, so for finding the number of regions, so in a particular flow graph, so you need to include a region, so which is outside the flow graph. So the next one is cyclomatic complexity. Cyclomatic complexity is nothing but it is used to find the number of independent paths in a program. So what is the use of independent paths is, okay, so in a particular program, if you want to test a program, so you need to find the number of independent paths, and you have to write a test case in such a way, if it tests that particular independent path, it is equivalent to testing the entire program. So now we are going to see about how many independent paths, right, are available, so in that particular flow graph. So how it can be found means, okay, so that is from the starting node to the ending node, there should be at least one new condition or any new processing statement should be there, right. So here, if you consider the path 1, so that is the node 1, so which is the starting node, and the node 11, which is the ending node, which is the path 1. If you consider path 2, so that is the starting node and the ending node, there should be a new condition or new processing statement, right. So that is node 1, so 2, 3, 4, 5, 10, again 1 and 11, right. So it forms the path 2. Whereas if you consider path 3, so that is node 1, 2, 3, 6, 8, 9, 10, again 1 and 11, right. So this is the path 3. And path 4, so which is from node 1, 2, 3, 6, 7, 9, 10, again 1 and 11, right. So that is the path 4. Totally, so there are 4 number of independent paths are available, and if you are writing a test case, so in such a way, if you test all this particular independent paths, it is equivalent to testing the entire program. So this cyclomatic complexity, it can be found in different ways. Okay, so like the first method is based on the number of regions, right, so in the flow graph. And the second method is cyclomatic complexity, so that is V of G, which can be found by the number of edges minus number of node plus 2. And here E is nothing but the edges and N is the node. And the third method for finding the cyclomatic complexity, so that is V of G equal to P plus 1. P is nothing but it is the predicate node. So what is a predicate node is? It is a node that contains a condition, right? So that we call it as the predicate node. Now we are going to find the number of independent paths in this particular flow graph. So there are three different methods. So first we are going to see the first method, that is based on the number of regions. A region is nothing but the area that is enclosed between the nodes and the edges, we call it as a region. And while finding the independent paths by using the number of region, so you need to include a region, so that is outside the flow graph. So here for this flow graph we are going to find how many regions are available. So if you consider the node, that is 1, 2, 3, 4, 5, 10 and again 1, right? So it forms the region 1. And if you consider node 2, 3, 6, 8, 9, 10, 4, 5 and 2, 3, so it forms the region 2. And the node, so that is 6, 7, 9 and 8, it forms the region 3. And as per the rule, we have to include a region, so that is outside the flow graph. So for that reason, so you are including a region that is outside the flow graph as R4. So there are 4 number of regions. So what is this 4 number of regions means? So it represents the number of independent paths in the program. And the second method, so that is V of G, so is equal to edges minus node plus 2. So edges is nothing but the number of arrows or the links, and the nodes is nothing but the number of circles, right? So in the flow graph, so there are 11 edges in this flow graph and 9 nodes in this flow graph. So edges minus node plus 2, which is equivalent to 4, which is nothing but the cyclomatic complexity. And the third method, so that is cyclomatic complexity, so which can be found by using the predicate nodes. So what is a predicate node? Is a node that contains a condition, so that we call it as the predicate node. So V of G equal to predicate node plus 1. So in this flow graph, we are going to find how many predicate nodes are available, right? So predicate node is nothing but a node that contains a condition, so that we call it as predicate node. So that is node 1 is a predicate node, node 2 and 3 is a predicate node, and 6 is a predicate node. So there are 3 predicate node, so plus 1, so which is equivalent to 4. And this 4, it represents the cyclomatic complexity or the number of independent paths in a program. By using the cyclomatic complexity, so we have found the how many number of independent paths are available for this particular flow graph. So in that, for this particular flow graph, and if you are designing a test case, so in such a way, so if it checks this particular 4 number of independent paths, it is equivalent to testing the entire program itself. Thank you.